far. There's more work to do, but this is a snapshot of where things are. We don't have to worry about our session surveys since we're here. So basically, the idea is I wanted to take, like dealing with inventory and stuff. Can you find out how much inventory is on hand? What product lines are your customers buying? What volume are they buying in? Can you do it hands-free? What Watson services are available to help you understand how much stock is available, who is buying, who's selling, what kind of trends can it spot? Because we have both structured and unstructured data in there. So what I'm interested in is what can we get out of the unstructured data, or finding relationships that we might not normally think of. That's where I want to get to. So some of the key concepts: speech to text, text to speech, build an interactive application using Watson's services, which are available via the cloud. But something that I think is going to resonate with a lot of organizations, IBMI shops, is how much of this data can I keep on the eye? I don't want to give up all of my data and put it in the cloud environment in order to have Watson operate upon it. What can I keep on the eye? And parcel out little bits of my data to Watson to process, come back with some results, but keeping the data on the platform. I think that's something that's still important to a lot of organizations. So I don't know if you've come across this sample database project. Bert, you have? Maybe? Okay, somebody has. The Business Intelligence Reporting Tools. This is from an Eclipse project, BERT. It is a business intelligence reporting tools. For my purposes, I'm not interested in those reporting tools. It comes with this sample database, classic models. It's model trains, vehicles, boats, things like that. That's what this sample database is. But it has some of the database tables that are normal and relevant to us, in offices, employees, sales representatives, customers, payments, things like that. So for my purposes, this is just a nice little database that it originated in MySQL, converted to DB2. And Mike and I have used this database a lot for testing out ideas, for sample applications with training customers, things like that. It's just a nice little database that the license is friendly for us to be able to use it in different contexts. So this little eye chart on the screen is the database schema. Oh, I don't even know if I have a little pointer. Who cares? Let's see. Employees are related to the office that they're located in. There's an office code. Employee number is related to customers. So there's a sales representative, a subset of the employees that work with customers. Customers, they better be making payments, and hopefully they are ordering things, so the customer number is related in there. Order number, order details. Obvious product code relates to the product line, and then so the order detail is pointing to the information for each product. So there's a lot more to a real database, but this is just enough to give us something to play with in terms of relationships between the tables. So you want to get to Watson. How do you get there? Bluemix. This is the URL where you can, if you get there, you don't already have an account, you can get a free account for 30 days. I've had mine for a few months now. I've not met any threshold where I needed to pay anything yet, which is nice. They've got several tiers. I'll talk about that a little bit. But it's a cloud-based platform as a service. It's got 130-something services for creating, deploying, managing applications. It's based on this open project, Cloud Foundry. Bluemix is IBM's implementation of this open source Cloud Foundry. So all sorts of programming languages and various categories of services.
So Bluemix
Yes.
is basically IBM's cloud offering, much like Amazon Web Services, AWS. Or
Yes.
Google.
So I don't know if it'll for the recording, but Bluemix is like it's IBM's cloud services offering, something like Microsoft Azure, AWS for Amazon. Yes, that's exactly right. And here are some of the categories.
Don't worry about the recordings, just for
Two of them, two big groups of these categories, infrastructure and platform. So infrastructure is a lot of what you were just talking about there. These two big categories. But these categories and the subcategories you see here are not mutually exclusive. When you're looking at individual services on Bluemix, some of them may fall into multiple categories. You can imagine that a lot of things are going to be implemented or accessible via some API. So they have APIs, the Watson services, Internet of Things. They have a number of categories. Yes, yeah, blockchain, a lot of banking, getting into this. Storage, cloud-based storage, using blockchain technology to verify the integrity of the data that is being stored so that anybody can independently throughout the system constantly validate that the data has not been tampered with. That's where the power of the blockchain comes in. I can't even pretend to get into the math involved, but that's the idea. The same thing that makes Bitcoin and all these other things work in terms of these cryptocurrencies, this is working for validating transactions. A Bitcoin transaction is like adding data to a file, modifying it. That growing chain of transactions of modifications can be validated to ensure that nobody has slipped in something that wasn't supposed to be there. Everybody's validating automatically the contents of that ever-growing stream of data.
Same as now there's people that can hack into the Bitcoin data mining.
Yes, one of my colleagues, as I was walking into the restaurant, texting my wife saying, "I'm here and I'm safe." One of my colleagues was saying that he had his own hosting service and development services before he started working at Zen. He said a couple of his servers had been hacked by some WordPress applications where some JavaScript was injected into. Basically, he ended up some hackers had set up portions of his servers as Bitcoin mining operations. Yes.
Wow.
You collect money when you are mining Bitcoin. So yeah, it's bizarre.
That's quite the virus.
Oh yeah. So I hope you can see this. We're going to obviously have the slides available. Our focus is on this one category, Watson. These are the Watson services: conversation, language translator, personality insights, text-to-speech, discovery, natural language classifier, retrieve and rank. I won't go into all of these here because you can read all about them on the Bluemix site. But these meet the needs of various aspects of cognitive applications, and you can apply them individually or in concert with each other in order to provide the functionality you need for an application, or to add functionality to an existing application. So,
Question on that
yes.
tone analyzer.
Yes.
Could that be hooked into, say, you know, when you try to get a human when you're calling into a call center, you end up yelling at the computer. Going,
That's exactly what
human being.
Yeah, tone analyzer.
Could it analyze the tone and sense the frustration?
That is precisely what it's for. To read the tone of text. Now, if it's someone speaking, it's translated. Actually, let's see if I
don't
do.
want to derail you.
Okay.
If you
Well.
type the message in uppercase, then it knows that you're
Yeah,
calling.
that's pretty elegant. Or it's my dad.
We can take a quick look at it. This talk, it was a 75-minute talk at Common. I tend to run long anyway, so I'll try not to do that here. I'm starting late now. No, running long is not what you want to hear. Yeah, I've got to do this talk again. Yeah, I do intend to skip some of these because one thing I learned delivering this talk at Common is there's some of these slides I don't need. I'll just leave them in there and kind of go past them. But I don't remember if you remember this scene from The Matrix, but the problem is choice with all these different services available. How do you know which of them apply to your situation, especially that Bluemix has a number of related services? If we had time to look at each one of those, you'd see that there are some, like natural language and a couple others, actually do not exactly the same thing, but similar things. So you have to realize that they overlap in one way or another. So you need to understand exactly what your application is supposed to do, and think about the scope of the capabilities and how deep you want to go in the application. So just as a quick example, you might need natural language processing for one type of application, but you need a different service to be able to handle like classification and understanding of natural language input on a deeper level. There's a light level of understanding for certain aspects, and then there's the total natural language processing, which can look at a number of aspects and give you more information about what someone is communicating in human language. I know that sounds really hand-wavy, but that's part of what you need to understand, what each service really does and what it does not do, and then figure out what set up, updating those services and so forth, and your initial ongoing costs. There's actually a lot to that. The structure and nature of the data that you're using has a lot to do with what service you would want to use. Does the structure of your data change rapidly, meaning that you'd have to retrain the service repeatedly? Because what you do, you set up the service with data to train it, to give it an idea of how it's supposed to act, how it's supposed to respond, and then it's able to handle new input based on what it's figured out the rules and relationships are. It can handle new input. If the structure of your data is changing, you may have to retrain more often. If the structure is fairly constant, but some of the content is changing, you may have to retrain also there. And the volume of data that you're working with is going to be important too, the size of your data. So generally, you're given an initial set of data, you train the system. When that training is complete, it's ready to be run live in production. And then you may retrain it to process new types of queries, do different types of analysis. I don't think I'll go into the cost so much, but there are tiers of usage and tiers of data. So you may have an initial fee, maybe a monthly flat fee, and then a per API call fee. The more API calls you make, the lower the price is per call. So far, I haven't exceeded any thresholds. Also, like for, I think the text-to-speech, like your first 1,000,000 characters is free, something like that. So.
Per API call? That's an interesting licensing model.
Or, well, again, some of them are per API call, but the amount is like really, really tiny.
In the short term, you turn that into a production application.
Well, it depends on what the application's doing. That's why they have different tiers within that pricing as well. So it's like from 1 to 250,000 calls per month. That's going to be this price. 250 to 500,000 calls per month. That's another lower price per API call. And then over 1,000,000 or over whatever, it gets lower and lower. And then they have, please call us, let's talk. You really want to, So back to the catalog. These are the ones that I thought would be most applicable to this conversation. This adds a natural language interface, and I'll talk about this a little more, to an application. Really, really suitable for chat bots or automated service, basically, where you would have somebody be typing in a question, I need help with canceling this order. Well, the service can handle that type of thing and have a conversation and drill down into what action needs to be taken. The natural language classifier, natural language understanding, I thought those would be useful. Speech to text and text to speech. I wanted to start with things that I could get my head around most easily, first of all. And those elements that would have to be in place for any cognitive type of application I'd want to build anyway. Text to speech and speech to text. So we'll see some of the results of that and some of the conversation. So I was thinking that the conversation service might be able to handle varying questions more easily and funnel them into the correct actions that I want to do. Because ultimately, what do I want to do? I want to take a question from a user, a salesperson or something, and turn that into what ends up being an SQL query in my database. So instead of having a very formal, rigid, structured language that a person would have to understand and use, do natural language, have this figure out what they really mean, and then turn that into SQL queries. But also use other services where, again, the data is more static. Some of the stuff in the tables, office locations or the relationships between salespeople and who are their customers, that may be more static and not changing as much as the transactional data related to orders and payments and things like that. That type of stuff that's changing frequently, that would be, I'm going to take the text, the human speech, and figure out how to make that into an SQL query. The stuff that's more static, we could basically make it a big chat bot and let Watson do that stuff so I don't have to code that. So I had actually initially rejected conversation for what I wanted to do here because all I saw conversation being used for was chatbots. I think it's possible now that I've learned a little bit more about how the API works, where I could take that and turn that into an actual SQL query. So basically, what you do is, and I'll talk about this more. I don't want to do the summary here, take too much time. But eventually I want to get to the natural language understanding service, where if you stay under the right thresholds, it's a pretty good demo, and it would be free. If you go above the threshold, this is one of those things where it starts at $800 a month if you just hit their usage threshold. But it can figure out concepts and keywords, entities, relationships between things, sentiment, emotion, things like that. So the more you want that service to be able to understand in this unstructured text, this language that's coming in, the more you pay. So the more you want it to understand these things like relationships and concepts, just figuring them out on its own based on the training data that you provide it, the more understanding you want it to have, the more you pay. So that could be
creepy.
Yes. But extraordinarily useful also. Also, I didn't want to surprise my manager with an expense report for this. So,
how
yeah.
incredibly useful it is. I'd like to hear more about your use example and then other real-world applications of this. So
The real world is going to be more impressive than my example, I guarantee you that. But like the day that I was doing my talk, I found out that Staples, you know those commercials with the Staples, the easy button?
yeah, that was easy.
Well, I didn't realize that. I thought that was just a gimmick, for their advertising. And but apparently they sell these these easy buttons. And I thought that, you know, if you see them in somebody's office, and I have, oh, that's a funny, you know, like a paperweight that you see on the advertising. No. You touch the thing, you tell it what you want, and it places the order. It asks you, based on stuff, it'll prompt you. You know, you're getting low on this type of copy paper and stuff like that. So, do you want to order some? And you can have a conversation with this easy button. They've implemented it with, guess what? IBM Bluemix Watson services.
Wow.
Yes. So there's a real-world example that kind of blew me away. The case study is on the website. I'll dig it up and find it. Yeah, I was surprised. So yeah. Ah. So anyway, I chose text-to-speech and speech-to-text for this first iteration. I did get some conversation stuff in here. So it's interesting you're saying creepy, because I'm gonna the text-to-speech thing. These voices, just a little bit here.
Tonality one that caught me there.
Yeah, it can.
I didn't realize that. That was a callable API now.
Yeah. So some of the challenges with this in general. Okay, taking unstructured speech, translating that to structured database queries, because some of this we want to do DB queries with. So correctly parsing the text that's coming in, building the appropriate SQL query from the text, and recognizing when the speech that we're given as a question, when to ignore it, when not to try to make that into a DB2 type query. That's part of my challenges here. So basically taking the question, who are my customers, translating that to, you know, select customer name from customers, joining on these tables with appropriate where clause and everything. How do I translate that type of stuff? And stepping back and thinking about this more, what are some of the challenges? What is the real intention behind the question? What context is surrounding that question, and how does that context change as you go from question, response, question, response, question, response? So you have to have some type of memory that's going forward throughout this interaction between the user and the system. As an example, 3 questions. Who are my customers? Using this for intention. How many times when you're saying, oh, my customer, are you thinking about the company name, or are you thinking about your point of contact? Who's my customers? Joe, Bill, Jack, Mary, or ABC company, YXZ company. So what's the intention?
Somebody's just being mean, trying to put it in a loop and said, who are my customers that aren't my customers?
There we go, yes. Knowing when not to attempt a query. Then, following that, where are they located? Do we mean the city, the state, province? Do we mean sales region? Where are they located? Oh, that's the Northeast region. So context, what do we mean there? These are challenges. Have I solved all these? No. Have I solved any of them? Well, who has not ordered in 3 months? Well, by now we've gotten into this little question response thing here. Who has not ordered? Obviously, we're talking about a result of the results that we've gotten previously from our questions here. We're talking about my customers, not all of them, who hasn't ordered in 3 months. Context again. In the first question, who are my customers? Presumably the person who's asking this question. How do we determine that? Is it a sales manager? Is it an individual sales rep, for example? Where are they located? We need to know that this is the results. We're talking about the context of the results of the first question. Who is not ordered? Well, we're talking about the results of question 1, not question 2. What is the appropriate context for this question? This stuff is non-trivial when we really think about it. So, getting to text to speech. This provides an API for converting written text to natural sounding speech. It's streamed back to the client making the API call pretty quickly. I was kind of impressed. I'm going to do some actual queries here over my phone. We'll see how that goes. I haven't tested it with that. But it's good for building voice-driven, screenless interfaces, maybe something in a vehicle, a car, or a kiosk, or, I think I may have hidden a slide. This is one I wanted to show you right after that sample database. After seeing the abstract for Common, someone who is in Franklin, I think, said, hey, I'm not going to be at Common, but I want to talk to you about this stuff. This is his actual scenario. They've got a product picking system that's voice activated. The system talks to their drivers going around to the warehouse and everything, tells them what aisle, bin,
Here
the
in
level.
Franklin, Tennessee?
I think it's Franklin. I think it's Franklin. It may be Franklin, but anyway, they've got an expensive system that the units take. The devices have the orders on the device connected to their IBM machine. It tells the drivers where to go, pick things up to fulfill a given order, and then they take them to where they bundle them up and actually ship them. But this is the picking part of it. They want to replace that with their own application if they can. They want to evaluate the trade-offs of building their own PHP application Watson that can do the same thing. So that's something that we're talking about with them now, which was another motivation for me to see how far I can push this concept instead of just making it a toy. Now I want to drive it and see how far I can go with it. So this is very relevant to people who happen to be a lot closer to us than we would have thought.
Yeah, we do that at our DCs.
You,
Can I get you to take that out of your pocket?
Is this
I
doing
think
bad?
it's causing it to drop out a little bit. If you can just sit it there.
If I can stay here, and
Thank
I don't mind.
Always talk to your pickers.
So, fortunately, the text-to-speech portion, which is fairly strong with Watson, could be used for this very well, I believe. So, let me flip through.
I get him out on the back end of that, pushing that.
That
On
code
the power
does,
system.
I'm sorry?
that code does voice recognition. They call in their
Mhm.
inventory, how many cigarettes they have, how much
That's not
fuel
crazy.
they have.
Mm-hmm.
And ADT Automotive, when a car comes into the auction, they can say front headlights broken, it's
Mhm.
got voice recognition.
So the recognition.
Yeah.
That makes it so much faster, I would think, for these drivers going around a warehouse. If this thing is telling them, go here, go there, they don't have to look down at something. They can keep their hands on their equipment. It's safer, it's faster, it's much better, I would think. So, just some other sample applications. Video, script narration, voiceover, reading text, emails, some of the things we've talked about here. Assistance tools for people with low vision. This is some of the stuff that I don't know if I want to spend a lot of time on. I mean, I'm happy to, but there's several different formats that it can present the audio output to you once it's transcribed it, I guess. Or actually, this would be, synthesizing speech. Transcription would be the other way. It has a markup language, kind of like XML, but it has a markup language that you can use to change the tone, the timbre, the pitch, the rate of speech of segments. So you can mark up text to control what it's going to sound like. You can select different voices and work with different languages as well. So they've got one male and female voice and sometimes multiple ones in different languages. It has what they call appropriate cadence and intonation.
Is it all synthesized voices or is it recordings?
Synthesized. I did an earlier version of this talk internally, and one of my colleagues in Germany said, the German doesn't sound very good at all. So they're still working on it, I imagine. It's got some shortcut things, good news, apology, and uncertainty. If you mark this text, this block of text with uncertainty tags, it changes it so it sounds like someone is not quite sure about what they're saying, or making it sound like an apology.
What's the difference between synthesize and recording? The stuff I worked on was recording. It just pulls it off the hard drive and throws it out.
This is not taking pre-recorded snippets of text and putting it together to speak the text input that was given. This is taking the text and, yes, in the sense like the sound of a T or an H or an S or something. It's taking these little bits, but so yes, it's putting them together in that sense. But particularly with the markup, by changing the rate or the pitch or things, that's happening dynamically. So it's not taking pre-recorded sound of the text and saying, okay, this is the block of recording we want for this text. It's taking the individual words and the components of the words, the syllables, and putting together the text there.
I guess there's all kinds of studies on performance and resource utilization, the trade-offs on, doing the synthesized versus the text straight out of a file.
Yeah.
Takes how much more processing versus.
What I'm going to do here is, this is my text-to-speech sample. We'll see what this does.
Customer requested special shipment. The instructions were passed along to the warehouse.
I don't know if you could hear that. I have no idea if you heard that in here. You did? Okay, good. I'll go ahead and hit this one again. And hopefully you can hear it.
Customer requested special shipment. The instructions were passed along to the warehouse.
Okay. That was no markup, no changing. That's just the default Allison voice with some text that it's just a little bitty PHP script I'll show you in just a minute, to send it to Watson and said, send me back the, you can think of it like an MP3. It's not an MP3 file, but it's taking the text, synthesizing the speech, sending that speech file back, that audio file, and the browser is just playing it. Now, what would you really do with that file? Any number of things. You could save it. You could play it through a device, talking to a driver or something like that. I have another one that this next one is taking my BERT database. It's going through the product table, grabbing a random record in that table, and just taking the product description. So there's a few hundred products in there. So it's just going to grab a random description, send it, and we'll see what comes back. It's truly random. I have no idea what's going to come out of it.
Features gold trim, full-size spare tire, chrome trim, chrome grille, opening hood, opening doors, opening trunk, detailed engine, working steering system.
Okay, that sounded pretty good. And again, I've not tuned that at all to make it sound more natural. I mean, it's obviously not a person talking, but think about what it did with the commas, with the pauses, with Oh, there was something else I caught in that particular one. I can't remember what it was now, but it sounded pretty good. And if I just refresh this page, it'll pick another record in the table. And I'm going to show you this actually here. Let me end the show for a second. Then I'll take my browser, drop it over here. And I can't see now. So, what was the name of that link? Pardon me while I look this up here again. Text-to-speech demo MyBrewMix. Okay. Text-to-speech demo MyBrewMix.net. Looks good. Here we go. I gotta find my mouse. Pardon me here. Okay, so this is a little demo that they can. I mean, you can put in your own text, or you can just use their text. You can download the audio file, or you speak it.
Conscious of its spiritual and moral heritage, the Union is founded on the indivisible, universal values of human dignity, freedom, equality, and solidarity. It is based on the principles of democracy and the rule of law. It places the individual at the heart of its activities by establishing the citizenship of the Union and by creating an area of freedom, security, and justice.
Okay, not too bad here. Now, here's some text that is marked up a little bit with some of these general tags like apology and, oh, what was it? Good news, and so forth. This one won't take too long. So, like here, you can see, I've been assigned to handle your order status requests, express as type apology. That will sound different than the following text.
Request. I am sorry to inform you that the items you requested are back-ordered. When those items become available,
Uncertainty.
maybe next week.
Who's tagging there? So, they have taken a number of these little tweaks, grouped them into a category, good news, you know, apology, uncertainty, and just made them easy to throw in there. So, it's kind of corny, but you know, you can see how this actually might be useful. Now, for the creepy one, it's too bad Mitch is here. To me, it's creepy. Yeah, to me, some of this is creepy. You'll know which one I'm talking about here.
Hello, I'm Allison, but you can change my voice however you wish. For example, you can make my voice a bit softer or a bit strained. You can alter my voice timbre, making me sound like this person or like another person in your different applications. You can make my voice more breathy than it is normally. I can speak like a young girl. And you can combine all this with modifications of my speech rate and my tone.
The little girl one kind of creeps me out. But, pretty interesting stuff here. I'm not going to use their demo stuff here any further, but this is the kind of thing that you can do. I will show you a little bit of HP code that I did.
So that's actually running on Watson hardware,
Yes, right.
and it only works on that.
Well,
Bluetooth cloud connection.
As far, the demo stuff is obviously their demo stuff, but I have an account. I'll show you how it's set up and everything. Can you see this okay? I hope it's fairly big.
I guess what I'm
But-
getting at
Mhm.
is there's the thought that eventually, I know there's a lot of horsepower utilized in that, but IBMI's got a whole lot of horsepower now, the higher end.
Would they bring that
Yeah,
where
sure.
you would run it truly
Maybe
locally?
a possibility of that.
I don't know the answer to that question. It's possible that they could do on premises at some point. They're amortizing or spreading the cost out over many users with a per API call rate right now. Now, everything that I am sending, and normally that you would send, they do keep it and use it to improve the system, but you can, for each API call, you can opt out. You don't have to send your text and have them keep it. You can opt out of that data collection so that your data is, yes, it's going to their cloud environment, but they're not retaining it after processing it and synthesizing the speech. The same thing for all of their other services. You can opt out of their keeping it to improve the service. Everything I'm doing is pretty innocuous. So this, I'm going to leave this slide in the deck, of course, but that's the extent of my PHP program that was my test program, the one where it said customer requested special shipment, blah, blah, blah. That's the sentence. I just gave it that sentence. That is the extent of the program to do that work. It's a very simple setup and call. All of this stuff is just getting the configuration for my my credentials to authenticate with the service, telling it what voice I wanted to use. The URI is most of that URL that you're going to be hitting, and I want to synthesize the text. I'm using the basic authentication here. You can use a token to authenticate as well. You don't have to use, compute your username, password, headers each time. You don't have to do that. You need to use a token. This is saying I'm sending, let's see, I'm requesting, yeah, I'm sending JSON. I can accept as a response the particular MIME type. I want, some streamed audio format, basically. And I've got all that squirreled away in a configuration. Here, this request variable, this is the request, my HTTP request that I am building to send to Watson. And I'm going to get back a response here. So I'm sending my configured request. My client is just my HTTP client that I'm using. Sending it to Watson, I get back my response. I am now, these are sending headers to the browser because my IBMI partition is like the proxy between me and Watson. My browser is making a request to my IBMI. It's making a request to Watson, taking the speech and sending it back to my browser. The same thing is going to happen when I get this to the point where I'm actually massaging the database and getting more complex information from the database. Same thing. Anything that's going to be synthesized speech, that result is going to come back from Watson. So anyway, I'm just basically I'm just dumping the body of the response, which is the audio format stream. My configuration, I had PHP developers in my talk, so I went through how I was keeping my credentials separate from the other configuration and merging all that stuff together. I don't know if you're interested in that stuff or not, but basically I've got some text to speech, speech to text. That's my database config. And so those are just the URLs that I'm actually talking to, that I'm actually sending my requests to in order to get my data back. Credentials, stuff, merging my configuration together. This stuff I'm not, it's really short, small things. the product description, where it's getting a random product description. Again, it's very simple code. Actually, I need to be over here if I want to display this here. Get right. It's just a function I wrote to get into to pick a random thing. All of this is pretty much the same as it was before, as far as the setup, building my request object, configuring my request, sending the request, getting my request back. That's what this part is here. Sending the request, getting it back, and printing the response. That's all the PHP code that it is to do, is what I've done so far anyway. So the speech to text, that ended up being a little bit tricky. Sorry to have you up and down everything here.
We can have that shut off if it's bugging you.
What? No, not at all. I'm standing up, I'm sitting down, you know, but.
It's fine since you took it out of your pocket.
Oh, this is good? Excellent. Okay. So speech to text, what is that doing? That's taking the human voice and transcribing it into text. So we're getting a written, data from speech. So voice control of embedded systems, transcription of meetings, conference calls, dictations. It can handle a number of different languages, some better than others. The interesting thing that this can do, it see this metadata object in the JSON response, these last two things down here. It does give you JSON as a response. It can tell you what its confidence level is for each word. The confidence that it is the word that it actually chose to use, what it thinks you actually said, the level of confidence of what it actually thought you said. And you'll see where that comes into play in just a minute here, because it didn't quite get what I was saying correct. And so what I'm doing now is trying to tune this so that it can pick up my speech better. Keyword spotting. This is something that's in beta right now, but you can tell it for this speech that you're listening to, look for these keywords. If you find these keywords, tell me that you found them in the speech, and again, tell me the confidence level that you have found these keywords. That's the thing that I was wanting to hone in on to use to help me build DB2 queries from the speech. What keywords do I want to look for, and what other words may be around those words nearby in the JSON. Exactly, stuff like that. Because what I need to do to make an SQL query, I've got to find some structure in there, and then find the variable thing that I would use in the where clause to actually get the records and columns and stuff that I'm actually interested in. So I need to find anchors that I can count on, those are the key words, and then look in the appropriate locations in the JSON response for words after or before in the appropriate place to give me the ability to pull a query out of that. Is it easy? No. But it's better than me trying to write something that will synthesize the speech, and, I mean not synthesize, but read the audio. This gives me something to start with. They've got mobile SDKs and things like that. Keyword search, I already mentioned that stuff here. Oh, and the keyword search right now, it's available at no charge. This keyword spotting. So I figure as soon as we help them train it enough and they make it worth paying for, then we'll start paying for it. Different interfaces, WebSockets, HTTP REST, asynchronous. I won't go into all that right now. But here was my first attempt. I basically recorded my normal phone voice greeting. And I said, okay, hello, my name is Clark Everts with Rograve Software. I'm unable to take your call at the moment, but if you leave your name, telephone number, and a brief message, I'll return your call as soon as possible. Thank you. That's basically my voice greeting. This is what it transcribed. Hello, this is or ever will when software mama, unable to halt the moment, but if you leave your home telephone number and a message of return your call as soon as possible, and. So.
Which that sounds like an Indian would be telling. So it really is accurate.
I'm not even going to go there because I'm being recorded. So my first attempt was not quite what I was hoping for. I did some more queries with it, and I asked it to give me some information about what it was, what possibilities, what other words did it think it might have picked up, and why did it choose the ones that it did. So I was surprised by this. When I said, give me the alternatives, what it does, it gives you back your timestamps, the words that it found, and this is the number of seconds from the beginning of the audio stream where each word begins and ends. Because if you think about it at a low level, it's got to, okay, this is the beginning of a word. Oh, that's the end of a word. Now go figure out what word that is. This is the beginning of another word. Oh, that's the end. That's what it has to do in order to parse our text. If you think about somebody speaking in another language, you don't know a language that you're not familiar with. You don't know where one word ends and another one begins. And when we are speaking our native languages that we know in a normal or rapid conversational tone or rate, we know where the words begin and end. But so it's got to figure out where they begin and end. So 0.13, 13/100ths of a second into the beginning of the audio, it picked up the beginning of the word hello. Somehow I took almost half a second to say hello, it looks like, or 4/10 of a second. But this is where I think some of this got confused. If you look at this, hello, this is, if you look here at the end of this, the beginning of is. Now obviously there's tenths, hundredths, there's thousandths, and smaller units here where there must have been a delay. But those are pretty close together. So I can see that if I spoke a little bit more distinctly, a little bit more carefully, maybe it could have an easier time of figuring out what I actually said. But what surprised me was it found 3 possible alternative transcriptions. They were exactly the same for the entire bit of audio except at the very end. The only place where it said I might have said something different was at the very end. I'll return your call as soon as possible. I said thank you. It picked it up as and. Well, it gave me different scores for and. It thought I might have said are, and it thought I might have said nothing. It couldn't figure out what else. So with a 62.8% probability or confidence level, it figured I said and at the end. So these confidence scores.
100%?
Yeah, I mean, it's a probability. It's a confidence of 0 to 1. 1, I'm completely confident this is what you said.
Okay, so
0, I have no idea. So,
okay, so 1.00 would be 100% confidence.
yes.
Okay, because if I'm thinking that's 100%, if he's less than 1%, he doesn't have any confidence.
Oh, yeah, this is,
Okay.
yeah, I didn't adjust their number for what we would think of as percent. That is 62.8%, 0.62 confidence on a scale of 0 to 1. My code for doing my speech-to-text demo here, just configuration stuff. I'm not going to worry about that. This is the rest of it, building my query. I'm writing this file. I'm getting this file. I recorded my telephone greeting. I saved it as this open source FLAC format. It's a lossless format. You can think of anything like OGG or MP3 or whatever. I just saved it there. I put it on the IFS. This is all running off the IFS. This is not on my laptop. I take that, I stuck it into the body of my request, sent the request. It came back with this. I printed this on the screen here when I actually ran it. And so just basically dumped the JSON description. So this is another neat thing here, turning to the conversation, Watson conversation. This is this natural language interface. You can type text in. What the Staples people did, they're using conversation, they're using speech to text. They're having much more success with speech to text than I did, obviously. But so somebody taps their easy button, they're speaking to it. I'd like to order more pens. Do you want the black pens or the red pens? Which ones do you mean? Based on what you ordered last, I think you meant these. Is that right? Yes, it is. Or no, I want those. It's truly conversational. Watson Conversation is the engine they're using for that. But it's not somebody typing in. They're taking speech to text. That text is being sent to conversation and other services and other coding. So that's why I think I can take the speech, get the text, and then get into something that I can parse and make queries from. So virtual agents, chatbots, things like that. That's what you see all the demos for. I won't go into this much, but they have all the documentation there, and they walk you through what to do. They've got sample applications too. None of them are PHP. They're all Python or Java and other stuff. But so anyway, there's this information available there. So the way this works is you train the conversation service by giving it examples of various intents. These are things that a person can intend to do. What are the intents? What is an intent? Something like answering a question, placing an order, processing a bill payment, canceling a process, turning something on, turning something off. What is the intent? So you give it examples of text that represent an intent. The specific thing that you're turning off or on, Watson Conversation figures out that that's not what's important. It's the text that means I want to turn something on. That's what it figures out. Or canceling something or whatever. So it recognizes the intent that's expressed in that input. And it uses the intent to choose the appropriate flow of dialogue through this network that you later build. I'll show you what that looks like here.
When it didn't recognize thank you, can you go in there and say thank you, and get it to gradually fix itself?
We're talking about two totally separate services right now because the one was speech to text. Now we're talking about Watson Conversation. I should have made that more clear a transition, but what I'm working on, what I'm reading about now from the Watson documentation is how to improve the recognition. I've just gotten into that part, so I don't have a good answer for you. But there must be, because it's being used in other commercial production environments very heavily. So there has to be. I could do a follow-up or maybe just a blog post or something like that that would be, I mean, this is an ongoing research project for me. So this is not the end of it. So conversation. So you give it examples of intents. The best case is if you have real user input that you can use. And then, so here's, so what I wanted for me here, I said, okay, what's some static data that's not going to change much? Finding the location of something. So this is the location intent for my little sample database. Customers, employees, and offices, they have locations. So maybe I can ask it to show it how to find a location of something for me. So here are some examples. Where is the customer Atelier Graphique? Where is customer Dragon Souvenirs located? What city is customer Diecast Classics headquartered in? These phrases are examples of the intent to find a location. So these particular examples of things, the particular things we want to find, that's not what matters. Watson is going to look at these examples of text and say, okay, they say this is location. Well, what in here expresses the intent of finding the location of something? What I did, I did a database query, and I grabbed all of the things that have intents, and I made a CSV file. The system gives you a web interface, a form you can fill out and put in an intent one at a time. Example, 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 example. I didn't want to do that. You can also import CSV files. So I did a query and created, with a little PHP script, a CSV file, and I uploaded that. And it automatically, when you update it like that, it just starts training itself. So it's done in a matter of seconds or minutes or whatever, depending on how much data you're giving it. And then you can start testing it right then.
So if you give it a company name like Genesco,
Mm-hmm.
which is just an acronym,
Mm-hmm.
it figures that out by looks at the letters and see how it's pronounced.
This has nothing to do with pronunciation. What you would do, this is where I said you wire up these collection of services together. You could take the output of Watson Conversation. It'll give you a canned response, basically. It'll give you a response. You would take that text and submit that to the speech-to-text the text-to-speech service. And that would give you the audible, oh, they're in the Northeast region. That customer is there. Or Mary, she's in the San Francisco office. It would give you the appropriate speech based on the text. But I'm taking multiple Watson services and hooking them together now.
Right.
I'm taking the output of one, handing it into the input of another one. So the example like Genesco would be the example of an entity. I've taken intents, which are, here's what I want to find. I want to find something. Entities are examples of the things that can be found. So an entity represents a class of object or some data type that's relevant to a purpose, relevant to an intent. Uses the entities to choose the specific actions to take to fulfill the intent. So it's clarifying the intent. Examples for which there is a location. Diane Murphy, these are employees, these are customers. I have no idea what I've got a trailing thing there for. But the different entity values could trigger different responses for the same intent. Finding something is the intent. Finding an office location is different than finding a customer. So this is where you train it on the appropriate response based on the combination of intent and entity. And that's where this dialogue flow, this is where you spend most of your time. It is possible to automate this because everything that you do here, you can do with the web forms that you fill in, or you can do via API. If you figure out how to do this with the API, especially updating an existing dialogue flow, it would go a lot faster. But you basically set up an intent and then and your entities, you've already done that. Then you create the dialogue flow. You say, if I have this intent and this entity or these other conditions, then here's the response. Here's the text that I want you to respond with. That response would appear in the chatbot window, or you would submit that to the speech-to-text thing or whatever you would be doing with it. And so you have these different conversation flows based on these conditions and the response. So one response could say, okay, well now we know that we need to figure out some other information, so we're going to ask another question or allow them to give us more input. So you have this flow of conversation. And this is what it looks like. This is for my example. This is a screenshot of what I came up with. You always start with a welcome. This is basically your starting point. That's your initial node in the flow. So I had just my find location intent. I had 4 responses set up, and then we'll look at the next thing here. So this is my welcome intent. This is the starting point. So if the bot sees that this is the starting point, which it always does, because that's where it starts, the response, I put in, okay, go ahead. So my bot starts with, okay, go ahead. And then that tells the user, it's like a prompt. It's like a command prompt. I'm ready to take your input. That's all it is. The last thing is wait for user input. So that's what this node is for, getting us started. So what I did here now, this is, again, you see at the top, find location. So if it recognizes that this is a find location intent, now it's going to look at the contents and see, all right, are we dealing with an employee entity? If it's Diane Murphy or Mary Patterson or Jeff or Leslie, one of the Leslies or Anthony, then San Francisco office. If it's Julie or Andy or Steve or Peter, it's the Boston office. There's several, I did several of these. So I've got one node, but it's expressing multiple possible responses for all this input. Okay, if there's anything else, it says, I don't know what you're talking about. Can you reword your statement? It's going to pick a random, one of these three. I just set it to be random. But going back to here, this conversation flow, this could have been represented with multiple nodes, but by packing in these conditional expressions here, I can have a lot of different input yield the same output. Now, what we've done is essentially hard code this. It's a chatbot. It's pretty smart for figuring out which intent and which entity, but it's always going to give us a canned response. You can add in other possible responses, variations and things, but it's basically a canned thing. That doesn't sound like really cool looking up my inventory stuff. That's very dynamic data. But if we look at the whole set of our data in our DB2 database here, some of this data could be more static. It's not changing rapidly. We could use this, and we could use an API to update this and retrain this part of the system and not have to build queries ourselves to do this. So depending on the nature of the data, how much it's changing and so forth, we could use this as is and just think of it like a chatbot. On the other hand, what we can do with the other the data that is more dynamic is we can still use this part to give me, to find out what conversation flow we want. And instead of having a canned response, because we can access this with an API, instead of sending back a canned response, we can do what Staples did and initiate some action, some other action outside of this conversation service, and then do a database query. So if someone's asking, what is the sales trend for the third quarter in our Montreal office? Okay, I can use the conversation, or maybe if I want to drill down a little bit further, have a little bit of interaction back and forth to give me something that gets me to a point where I now have enough information and I can extract from this here. I can make my response something that's not a response that's going back to the user, but a response that's going to me, the programmer, RPG or PHP, whatever. I now have some structured information from this unstructured input. That's something that I can parse more easily and build an SQL query with.
You could say, what's Leslie Thompson's employee number?
Exactly.
Right.
Mm-hmm. Mm-hmm.
SQL select.
Exactly.
So this is basically like building an artificial intelligence node,
Mm-hmm.
nodes,
Exactly.
connecting them together.
Exactly. Yes. That's essentially what we're doing here. We're telling it in here that we're saying if it figures out that what the person entered in, speech or typing or whatever the input is, if it is expressing the intent, find a location or show inventory trend or whatever, who are the customers who are slow on paying their invoices over the last 6 months? You know, these various intents. If it recognizes the intent, now we can drill down into particular entities if we want to, and then either give a canned response or take some action. And since, again, I have access to the information in here, there's a bunch of metadata here that you can get via the API calls. I can extract that and translate that into stuff that we are familiar with, you know, programmatic statements and database queries and things. So it's leveraging the artificial AI cognitive stuff and helping us build very specific, you know, DB2 type things.
Trends
That'd be
would
wonderful.
really be complicated, but you could say, how much do we have on hand of red paint, whatever,
Exactly.
yeah, with an SQL and answer.
That's the kind of thing that I was hoping to wow everybody with at Common. But I had some the hiccups, especially I spent more time trying to get the speech-to-text thing working the way I wanted it to. So that was part of my learning here. Okay, I've got to look at this as a long-term thing over a few months here to figure out how to make this work. But you see the things that should be possible that I want to get to.
I mean, there are products that will take voice commands that you could speak into a headset and it'll translate that into a database input, you know, an API-based input.
Exactly. I want to do it too. That's what I'm playing with.
This is a different way to do it, though. By using Watson, you've leaped forward far beyond voice to text.
Yeah, exactly. Oh, yes, yes.
Because using the Watson commands, now suddenly I could garble my voice, and perhaps that could still recognize it because it's a far more advanced engine behind the scenes.
That's what I'm hoping for. So far, I couldn't get my telephone greeting right, but I'm sure that's just me in my early days with the system. But yeah, the possibility.
How long did that take you to put together?
Let's see, because I'm doing customer work and this is my spare time, I didn't record it. I thought about this. I should have recorded it so that I could answer that question because that's a very good question. And I thought, you know, some smart person's going to ask me that. I would say approximately.
Blind squirrel finds a nut once in a while.
Yeah. Stop to watch twice a day. That's right. I'm going to say really just playing around, reading a little bit of the documentation stuff. Definitely within a couple of days, and that's starting, stopping. I mean, I would work on it one day, and then a few days later be able to get back to it. So a lot of that is getting back up to speed with the context. If you could spend just one solid day with it, you probably would be where I am easily. Just one day, from start to finish, getting your Bluemix account, and you know, figuring out how to get to the categories and starting, you know, picking the service and stuff. I'd say a couple of days you'd be where I am. I don't think this is super hard stuff yet.
Google or any of the other, I mean, if I pick up my phone and push the microphone and say directions to Shoney's McGavitt Pike, it translates that text.
There's a lot of competitors in this space. My German colleague who said, you know, he tried out the Watson thing for in German. He said, it doesn't really sound that good. He tried out Google's API as well, and he said, now that sounded good. So
it's because they have
on the
1,000 times the volume of data samples.
Exactly.
It's all about the data samples.
That is exactly right.
Garbage in, garbage out, or good, you know,
Volume
the
in.
larger volume of the data
Think about how many years of
The intent of what's spoken to Google is 90% location or.
that's true too.
Not necessarily. I'm all the way down here. I was responding to email on my.
every word you say
And it picked
goes
up.
to their service.
It picked up everything I said.
Yeah, but
Perfectly.
all
It's
you're
not
doing-
always that good, but
But you're just.
I'm amazed at how well it picks up.
But all you're
Yes.
doing is converting straight speech to text. You weren't asking it to find a customer
Right.
location something.
No.
So, yeah, I think there is probably
It's just
more.
an application of the same data, though.
Mhm.
And you know what? Apple's gathering it through Siri, Amazon's gathering it through Alexa,
Oh,
Google's
yeah.
gathering it.
They are really working hard to beat each other out on all this. So, I mean, you can see, you recognize some of the potential here. So, yeah,
In disk drive
this is
places.
huge. Yeah, investing in disk.
Yeah, no kidding. Think about how
Um,
much volume that is.
That's the benefit of capitalism.
Mhm.
Because in Russia it will be just one company and nobody is competing with
Yeah.
nobody
Mhm.
Good job.
and we cannot get it.
Mhm.
Yeah, but
Yeah.
Amazon and Google and Apple, they're gonna start, these AIs are gonna start a war with each other. Humanity's gonna be the victim.
And North Korea's gonna do that EMP blast and none of this cloud crap's gonna work.
Yeah.
That's why
There are actually some websites where people are collecting. Basically, they want the machines will eventually become intelligent and they will make decisions and act. What we want to do is make sure that their values are in line with our human values. So there is at least one site, I think Elon Musk might be involved in it, but there's some big AI researchers that they want people to answer a whole bunch of questions, this huge questionnaires, and trying to see what is important, basically like morality. What are the values that we as humans want these AIs to eventually model?
Sure,
It's the behavior that matters.
That's a dating service.
Self-driving cars. I mean, my
Yeah.
car would just plow you over.
That's your intent.
Yeah, but you're not programming the Tesla.
Most people on the roads these days, they don't need an automated car to do that. They're doing that very well themselves. You know, just get out of my way. And but where do I want to go from here? Continue with the speech to text to improve that. Use the spotted keywords, parse text files, build SQL queries. But I really actually want to lean more on the conversation now that I've gotten smarter with that. So the text-to-speech, spotted keywords, that is useful to me. I think that's going to be a part of this. But the conversation, I should have put the bullet in here, other Watson services. The conversation service, I think I'm going to be able to leverage that a lot more than I thought I was initially. I want to get into the natural language processing. That's going to cost some bucks. I want to find ways to do trend analysis, find correlations that I might not have thought of. I mean, we can think about things and we got the relationships of the data, and we can think of queries that reach into here, reach into this table, that table, and we know some things to look for. I want to see what some of the other Watson services can give me in terms of correlations that I might not have thought about myself. And there are companies that are using Watson to look at their internal data. They're not going to share that with anybody, but they're looking at their internal processes and structures, and how well do everything from support case resolution data to marketing and sales and inventory and all these type of things to figure out how they can become more efficient. And
You could use the Watson tonal analysis
Mhm.
to analyze 10,000 support calls to see
yes,
what percentage of support calls resolved
Mhm.
positively where the tone of the caller was
And-
positive versus negative.
and not have to rely on that tiny minority of customers that actually say, yes, I'm very happy with this resolution. Most people ignore that stuff.
Right.
Or this
You
just
can
occurred to
need a
me.
survey, you can just read people's.
Companies, internal companies' emails and stuff. The sentiment analyzer and the tonal, and there's a couple services that are again related but don't do exactly the same thing. Just scanning all the email back and forth, or your instant messaging internally, the internal corporate back and forth between employees. What's the morale of all these different departments? How is everybody doing?
Big
So
brother.
you want it's Big Brother on the one hand. On the other hand, it's, hey, we have a growing problem here. Do we want to address this and correct this before we have people at the point where they want to walk? I mean,
Could HR use that to find the aggressive communications?
yes, definitely with what I know it can do. Yeah, you could find that. Yeah, this guy's going to go postal. Here's a guy going to go postal. So, or could go postal. But
This is
now,
our databases. This is our stuff.
how do, think of all the ethical and, there's a lot of concerns here, but technologically, what is possible? You can see good and bad in what's possible.
Voicemails to see who's going to go postal.
Mhm.
Right.
But and do it without a person invading the privacy of all the employees or whatever. Have this objective thing over here, but again, how well is it trained? Where do you get the data to train this thing to analyze this? So anyway, that's.
I think they can hack into that and get your fellow arrested because they're home.
I don't have to do my dog and pony because I intersperse that throughout the rest of this. So we're actually, that's basically it though. Thank you much. So more, and that's who I am.